Hi everyone, welcome to KMLS Chemistry channel. In this video, I will be presenting part 2 of Introduction to Organic Chemistry. Every organic compound has one or more functional groups. The term functional group refers to an atom or group of atoms in an organic molecule, which characterize the molecule and determines its chemical properties. Next, I'm going to show some examples of functional groups to relate to the meaning of the term. So there are 6 functional groups shown here. The functional group can be an atom, such as halogen, or group of atoms, such as carbon-carbon double bond, carbon-carbon triple bond, OH group, which is known as hydroxyl, C double bond O group, which is called carbonyl, and COOH group, which is called carboxyl. So these three exist in the form of group of atoms. When we see carbon-carbon double bond in a compound, we know the compound is an alkene. When we see OH present in a compound, then that compound is typical of an alcohol. When we see COH, we know that the compound is a carboxylic acid. So functional group actually characterize the molecule. And functional group is also the site of reaction. Yeah, when reaction is taking place, the carbon that bond halogen will undergo changes. For carbon-carbon double bond, this doubly bonded carbon itself will undergo changes when it is reacted with a certain reagent. The same goes to OH group. In reaction, the carbon that bonds the hydroxyl group will undergo changes. So that means functional group also involved in chemical reactions, which means that it determines the chemical properties of that particular compound. What are the importance of functional groups? First, it is the basis for division of organic compounds into different classes. Functional group is the site of chemical reaction. A particular functional group undergoes the same type of chemical reactions. Lastly, functional group serves as a basis for naming organic compounds. The next key highlight is homologous series. What is homologous series? Homologous series refers to the series of compounds where the successive members differ by a constant CH2 unit or 14 mass unit. Members of the same homologous series are called homologs. Homologous series is also often referred to as the class of organic compounds. So if you are asked what is the class of a certain organic compound, It means you have to name the homologous series. The 4 characteristics of homologous series. First, homologous series is represented by a common general formula. The second, members of the same homologous series have the same functional group and chemical properties. The third, successive member of a series differs by a CH2 group of 14 mass unit. And the last, there's a gradual change in the physical properties down a series as the number of carbon increases. This is an example of the homologous series alcohol. Alcohol can be represented by the general formula CnH2n plus 1 OH, where n takes the value of 1, 2, 3, and so on. When n equal to 1, there's only one carbon atom in the alcohol. When n equal to 2, there are 2 carbon atoms in the alcohol. N equal to 3, 3 carbon atoms are present in the alcohol. Inspecting the molecular weight of 2 successive members, the difference in molecular weight is 14 mass unit. This is due to the presence of an additional CH2 group as the number of carbon atom increases by 1. Next is the functional group. Alcohols are characterized by the functional group OH, which is known as the hydroxyl group. And due to the presence of the same functional group, alcohols have the same chemical properties, which means that they undergo the same type of chemical reactions. An example is dehydration reaction, where an alcohol is converted to alkene. So the example on this slide illustrates the 4 characteristics of a homologous series. In this slide and the next 4 other slides, I'll be showing some common functional groups and homologous series. You may observe the atom or group of atoms for each functional group, the name of the functional group, the general formula, and I have also included the IUPAC nomenclature, the general IUPAC nomenclature for each functional group, and one example of molecule for each functional group. This is a question on identifying functional groups that are present in a molecule. So the first molecule, it is a big one. So we have to look out for the functional groups and circle them. After that, name all the functional groups that have been circled. So the first functional group, the next, and then the next. This is a fourth. And the last one. So we are able to identify 5 functional groups present in this molecule. So now we are going to name each and every functional group. So I just label an alphabet for each group. Okay, what is functional group P? Yeah, functional group P is called carboalkoxy. Q is carbonyl for the homologous series ketone. R is benzene ring. S is hydroxyl group. And T is carbon-carbon double bond. Q is also a big one. The first functional group, second, third, fourth, and the last. So the first functional group is known as carbonyl group. The second, carbon-carbon double bond. The third, halogen. This is amino group. And the last is carboalkoxy. Now let's move on to the next molecule. This is the first functional group, carbon-carbon double bond. The second, halogen. And the last, carboxamide group. The functional groups are already indicated from A to E, alphabet A to E. So we are supposed to name the groups. So for A, yeah, A is actually OH group. It is known as hydroxyl group. B, C double bond O. This group is called carbonyl group. C is this N, yeah. So it is amino group. D is the chlorine. So it is the halogen. And E refers to the whole C double bond O group. And this group is called carboalkoxy. This is an additional group here. It's not indicated by using any alphabet. This is carbon-carbon double bond. Another question, name the functional groups labeled with alphabet A, B, C, D in tryptophan molecule. A is already circled here, it's an amino group. B is carbon-carbon double bond. C is also an amino group. D is carboxyl group. So these are questions on identifying functional group in a given molecule. Well, that's all that I have for you.